recording. Okay. We have to write formulas and we have to name. So there's two things we have to do. Okay. We can be given the formula, okay, and we have to come up with the name, or we can be given the name and we have to write the formula. Okay. When you have nonmetals, covalent compounds, this is how you do it. So we're going to go through and show. Okay. At the end, okay, of your name, you're going to always end in IDE. Okay, that's actually kind of going to be common for all of our classifications. So if you have chlorine is your last element, we would call it chloride. You would drop the INE and add IDE. Okay. If you have nonmetals, you're going to use these Greek prefixes. So you just have to know these. They're not that hard. Okay. If you have one atom, it's mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, octa, nona, deca. So you have to learn these. Okay, they're not terribly hard. Like I said, we're going to practice them. Okay, if you have a single atom in your first, so let's think of carbon monoxide. Most everybody's heard of that before. You just have one carbon. You don't have to say monocarbon. Okay, you can just say carbon. It's understood that there's one. Okay, so that's where do not put mono in front of your first nonmetal. Okay, if you just have one. All right. So if we look here, let's try this. We're given the formula, and we need to name P2O5. So any guesses how we do this? What do you think we would write? Exactly. All right, so we would go up here. We have 2, right? Everybody see that 2? And we know that that 2 goes with di. So we would say diphosphorus. Okay. And then we have 5 oxygens. So we go over here, and we have penta, oxygen. We drop the ending, and we add IDE, right? So pentaoxide. Technically, if you have 2 vowels next to each other, pentaoxide, you drop the A because it's part of the prefix there. So it would be pentoxide. So P-E-N-T-O-X-I-D-E. Okay, so let me show this. So you would have A and O next to each other, so you drop the A. Because it's not really, the O is very important because it's the beginning of telling you that it's oxygen, so you leave it. Okay, you will have the name of the element on your periodic table, like I said, so I will count off if you spell things wrong because you have it in front of you. Okay, so especially fluorine, I tell everybody, I get that spelled wrong more than it's spelled right. It's F-L-U-O. It's not F-L-O-U. Okay, so be sure that you write it correctly. Okay, so we're given the formula and we just named it. Okay, now we would be given the name. So here's tetra-arsenic hexoxide. Notice that if you have 2 A's together, you leave the A's. I know it's a little bit of a confusing, but it sounds better, tetra-arsenic. Okay, hex oxide, so the A was dropped, okay, and there's the oxide. All right, and I'm not too picky about that stuff, so you actually sometimes see it written either way with the vowels next to each other. Okay, so now we have to write the formula. So we want to write something like this. Okay, so if we have tetra-arsenic, first of all, you have to find arsenic. So find arsenic and see what the symbol is. Anybody? Okay, it's AS. It's not AR because AR is argon. Okay. All right, what's tetra stand for? 4. So we have AS4. Okay. And what does hex is 6, and we know oxide is oxygen. So there we go, As4O6. Okay, let's name these. We're going to do lots of practice through the class. So we're naming, so we're given the formula. So we already kind of mentioned this one. Okay, we have 1 carbon and 1 oxygen. So because we have just one, we don't have to say monocarbon. We can just say carbon. All right, we have 1 oxygen, so what prefix is that? Okay, but the prefix is mono. Okay, once again, if you have a double O, it's not it's going to be monoxide, so you drop one of the O's. Okay, so you would so there's mono, there's your, okay, but we know that it's monoxide, not, so if you have 2 O's next to each other, or an A and an O, you're going to drop one of those. But if it's 2 A's, you leave them together. So it gets a little bit confusing. Okay. Okay. We have 1 sulfur, and because it's our first atom, we don't have to write mono. Okay. We have 3 oxygens, so what's going to be our prefix? Anybody remember? Yep. It was tri, so it's going to be sulfur, trioxide. So we always end in IDE. Okay, we have another sulfur, so all of these were just 1. Okay. Do you remember the prefix for 6? Okay. So hexa. Then what do you think so it's fluorine, but if we drop the I and E, it's going to be fluoride. Very good. Okay. So we took a formula, we named them using Greek prefixes. Okay. What classification is this? What are we naming here? We use Greek prefixes when we are naming what? Covalent compounds, nonmetals, or you can call them anions, whatever you want to call them. Okay, so this is the way that we name. Okay, if we write the formula, all we do is look here and see what our prefixes are, and then carbon, we know our symbol is C, and because there's nothing next to it, that means it's understood that there's how many carbons? 1. Okay, tetra stands for 4. So we have CCl4, because chloride would be chlorine, but just IDE instead of INE. Questions? Good deal? Okay, this is the second classification. Like I said, none of these are really extremely difficult. It's just you have to remember what these classifications are and be able to put whatever I give you, whatever compound, into these classifications. Okay, if you have a group 1, 2, or 3 metal and nonmetal, then this is how you're going to name and write formulas. Okay, our first point is just like what we saw on the last slide. We have IDE is going to be the ending for our anion, or for our nonmetal. Okay, so this is an ionic compound, metal and nonmetal, with a group 1, 2, or 3 metal. Okay, in this classification, you do not use Greek prefixes. That is a very common mistake, is to take what we just learned and now in this classification accidentally use those. Okay, you do not use Greek prefixes or Roman numerals. You don't know what those are yet, but later you will. And when you're reviewing, you'll know in this classification you do not use Roman numerals or Greek prefixes. Okay? It's actually the simplest naming of all, but it's the most missed because students want to do too much. They want to add a prefix or add a Roman numeral because that's what we're going to learn today. We're going to learn all the different things that can be done. Okay? But for this name, okay, the name would be aluminum sulfide. That's it. Okay? There would be no di, tri, anything. Okay? So the name here is aluminum sulfide. All I did was found Al. Now that's aluminum. S is for sulfur. You drop the ending and add IDE. Okay? All right, what about the next one? What would we name it? Yeah, everybody agree with her? Exactly. Okay, so naming, simple. You just name the metal, name the non-metal, end in IDE. Okay. For writing a formula, I'm going to show you a shortcut. So we've actually done this. So back in chapter 7, when you had the chart and I said you can take the metal and the non-metal, and we looked at our Lewis dot diagrams of how many electrons we would donate to the metal, or to the non-metal, excuse me. And we also looked at our electron diagrams, and we saw this. So you came up with formulas in chapter 7. You may or may not remember it, but you did. Okay, so you can do that, or we can do a shortcut. Okay, and so I'm going to show you the shortcut way, especially when you're naming. It may take you a while on the exam to sit there and draw out all the diagrams and, you know, okay, well, it'll donate this many, so I need this many atoms. Okay, so I'm going to show you a shortcut. The main idea, and we're going to use this a lot, is that the overall charge of our compound has to be 0. Okay? It's called the ionic charge. All that is the charge on the ions. Okay? So we have a cation and an anion here. Okay? Why do you think it has to be 0? Why do you think the overall charge has to be 0? Yeah, so it's stable. And you showed this. You didn't know that you were doing this, but when you were coming up with how many electrons does the metal or non-metal want to gain or lose, and if they combine together, you know, how many atoms would I need? Okay, in chapter 7, that's what we were doing. We had to come up with a charge that would equal 0, because that means your octets are satisfied. Okay? So what we're going to do is we're going to do something that we call swapping states or swapping charges. Okay? And it's just a real simple way to do the math. It takes 2 seconds, not even really math, okay, and come up with your formula. Okay, so what you're going to do, here's an example. If you had rubidium sulfide, okay, how do I know that rubidium has a charge of +1? It's in group 1. Okay, the first thing I did was I looked at this right here. I looked at rubidium sulfide, and I saw, okay, rubidium, it's in group 1. It's a metal. Sulfur is a non-metal. So I know this is classification 2 that I'm teaching you here today. This is our second classification. Okay, so what you're going to do is you're going to write out the oxidation state. So you know rubidium is always +1 because it's in group 1. Okay? All right, look at sulfur. Okay? How many electrons does sulfur want to gain? 2. You know that because it's 2 spaces away from argon, right? So it wants to gain 2 more electrons. Okay? Then all I do is I simply swap those numbers, and it just works. Okay? So if we take that 2 and pull it down here, and the 1 here, we have rubidium, we have a 2 there, and then we have an S. Okay? So instead of, you would have found this out the same way had you looked at, you know, your diagrams and seen that you're going to need 2 rubidium atoms for every 1 sulfur. Okay, it makes sense, right? Because rubidium only wants to lose 1, so you have to have 2 of them so that sulfur can gain 2. Okay? So the charges cancel each other is the main idea, that your charge ends up being 0. Okay? And like I said, you can look at the diagrams if you don't want to do the swapping, but most students find that to be the easiest. Okay, you're not swapping the charge really. Okay, you can't have -2 atoms. Okay, so don't try to swap the negative down here. Okay, you're not going to have negative or positive there. You're just taking those whole numbers, just the number, not the charge on it, and swapping it. That's all you're doing. Does everybody see how that happened? Okay. Okay, let's do the bottom one first. Let's name MgCl2. Okay. First look here, we have magnesium, it's in group 2, and we have a nonmetal. So we know it falls under this classification too. All right, so how are we going to name this? Exactly. It is not magnesium dichloride. It is just magnesium chloride. Okay. Okay, to write the formula, what we're going to do is we're going to break these down. So sodium is in group 1, so it has a +1 charge. And chlorine is in group 7, so it has a -1 when it's chloride. Everybody agree with that? So we have a 1 and a 1. If you have a situation like that where you have a +1, -1, right there you know +1 -1 equals what? 0, right? So you're going to have 1 atom of both. I mean, you can go ahead and swap the 1 if you want to, but we get NaCl. Okay, magnesium has a +2. Everybody agree with that? It's in group 2. All right, what about bromine? What's its ionic charge? -1. Okay, if we swap these numbers, you don't have to write the 1. I mean, I don't count off if you do, but there's our formula. The 2 is swapped down. I don't show the 1. It's just typically not shown. Okay. What's the oxidation state of oxygen? -2. Okay. This is a situation again where you have +2, -2 equals 0. So you don't need to swap those 2's. Okay, so you end up with MgO. Okay, a formula is the smallest whole number ratio. So if you look there, that's not the smallest whole number ratio that you could have. Okay, because you could divide both of these by 2, right, and get 1. Okay, so if you end up with your charges being the same here, 2 minus 2 is 0, then you just leave it as the 1 atom. You don't have to swap because your charge already cancels. All right, questions? Okay, first classification, non-metals, we use Greek prefixes. Second classification, group 1, 2, and 3 metals with non-metals, ionic compounds, and this is where we just name it without anything extra added to it. And then to write the formula, we just swap our states. So you have to write out the oxidation state and then just swap them. All right. Third classification. This one is a little bit more complicated, okay, but I'm going to try to make it easy for you, easy as I can. Okay. This includes transition metals, so anything in that group B area, okay, in the middle there, and then includes tin, antimony, lead, and bismuth, which we already pointed out where those are. Okay, the reason that these are in a different classification is because they have variable charge. Okay, that means that a transition metal doesn't always have the same oxidation state, like our group 1, 2, and 3. Okay, group 1, 2, and 3, we know they're always 1, 2, or 3. Okay, but for transition metals, that number can change. They can have a different oxidation state. So we can't just say iron always has a 2+ charge, because that's not true. Okay, it can also have a 3+ charge. Okay, therefore we have to do a little bit extra work on these when we are naming them. Okay, when you name, you put in Roman numerals outside the name of that metal, okay, you put the oxidation state. That means this number here, the charge. Okay? That 3, that 2, that 1, that 2, they are not the number of atoms. Okay, so I have that here in red. Okay, the Roman numeral is the oxidation state. Okay, so when you name these, you're going to name the metal, and then in parenthesis, you're going to put the oxidation state, which we have to find it first before we can put it in there. Okay, but can't say that enough. This number here, this 6, doesn't mean I have 6 chromium atoms. It means that it has an oxidation state of 6. Okay, everybody with me there? Okay, so here's just a few. We won't do all of them, but you notice a few of these actually do just have one oxidation state. So they're kind of exceptions to the rule. All right, here, mercury, gold. So all these have, 2 oxidation states that we have to try to figure out which oxidation state are we in. Okay, and then we notice over here, which is what we expect, our nonmetals in our group 1, 2, and 3, they always have the same oxidation state, which is why we have different classifications. Okay, so this right here is the hardest part of the naming. Okay, it's not that it's even hard, it's just to remember to do this. We actually have to do a little bit of a calculation here to find the oxidation state. So if you're writing notes or doing whatever, I would highlight this. This is the only time that you have to do a little calculation to solve for the oxidation state of a transition metal. Okay, so we're in classification 3. Right, so our rule here is still that our total charge for the molecule or for the compound here has to be 0. So that's really what it comes down to, and it's a very simple math. Okay, so if we look at I'm just going to basically redo what's already up here, but just to show you. Okay, what we're going to do is we're going to set everything equal to 0 so that our number of atoms and charge has to be 0, right? We said that it has to be that because all of our octets are happy when the ionic charge is 0. So what we do is we go over here and we look. We have one understood manganese. Be sure you don't get manganese confused with magnesium, okay? Mg is in group 2. Manganese is a transition metal, okay? So be sure you don't get those confused. All right, we have one manganese, okay? And we're going to say X. We don't know what its oxidation state is, okay? Because we know it varies. Okay, so we're just going to put an X there. So if we were to write this out, we have MnX because it's a transition metal. We don't know if the oxidation state's 2 or 3. Okay, we don't know. It's not in group 1, 2, or 3. But we do know that our fluorine is in group 7, so it always has a -1. Okay? Questions? Any? Okay. So we have one, I'll write manganese out here, and we don't know its oxidation state. So we're going to solve for X. We're going to find the oxidation state. Okay, and then we have 2 fluorine atoms. That's a lot of times forgotten. You have to take into account both of the fluorines. Okay, and we know that our fluorine has a -1 charge. This is our fluorine atom. So you can go about solving for X however you'd like from algebra, but these are going to be very simple problems. So how I look at this is I say, okay, what does X have to be for this overall equation here to be 0? What does X have to be? 2, exactly. X has to be equal 2 because 1 times 2 minus 2 equals 0. Okay, so you just found the oxidation state or the ionic charge of the transition metal. Okay? This is the only time that you have to find it is when you are naming in classification 3. Okay? Questions on this? Does everybody know where I got the numbers from? Okay, it's number of atoms times the oxidation state for the ionic charge. Okay, we don't know manganese, so it's X. And we have 2 fluorines, and we know that it always has a negative 1 charge. Okay. Okay, so we're going to go through the whole thing. So we just found the oxidation state. Okay, where is that number that we just found? Where do you think it's going to go in our naming? It's going to be in what? Parenthesis, right? And we're going to write it out as a Roman numeral. Okay, so that number right here, that 2, is going to be the Roman numeral that we put into the name. Okay, so step 1, this just kind of breaks it down for you. We have to find the charge of the cation or the transition metal. Okay, so we just did that on that problem. Okay, and then you're going to name the cation by its element name, just looking on the periodic table, and then you use a Roman numeral. So we did, what was it, manganese. So it would be manganese 2. That's supposed to be a Roman numeral there. Okay. All right, and then you name the anion by ending in IDE. And then 4, you put it all together. Okay, so I think we had a fluorine there. So we would say manganese 2, what? Fluoride. Okay, so here's all the steps, but we're just going to talk through them. This is just to help you when you go back and you're studying. Okay, the first step says that here's our formula. We have to find the oxidation state, right? Okay, so if we look at this, we see iron, and that right away we know it is a transition metal, and so we have to think about this classification 3. Okay, so what we're going to do is we're going to find our, I know I've already given the answer right here, but we're going to find the oxidation state. Okay, so if we look over here, we have 1 iron atom, and we don't know its oxidation state. It could be 2 or 3. Okay. Then we have 2 chlorine atoms. And what's the oxidation state of chlorine always? It's a halogen, so it's -1, not just 1. You got to be sure that's negative. Okay? So X has to be what? 2. 1 times 2 is 2, minus 2 equals 0. So then we say Fe is iron. We look at our periodic table, and surely we can all spell iron, but there it is. Okay, so we have iron, parenthesis 2. And like I said, that doesn't mean we have 2 iron atoms. That means we have 2 as the oxidation state. Right. Now we have Cl at the end. So we know that we drop the INE and add IDE. So that's been something common for all 3 classifications, right? So chlorine becomes chloride, and so our final answer is iron 2 chloride. Okay, let's name these. We'll do these together because we'll do some more practice at the end. All right, first thing you have to do is recognize which classification, and we know that we're in classification 3 right now. So we have iron and tin, both of which are transition or fall under classification 3. So the first thing we have to do is we have to find the oxidation state when we are naming these in classification 3. So we have now 2 iron atoms, and we do not know the oxidation state. And we have 3 oxygen atoms, a -1. Okay, you cannot forget that 2 and 3 that go in from the number of atoms. Okay. Oh, sorry, yes. I was used to doing the fluorine and the, yeah, thank you. Okay, so if you look at this, we get -6 over here, so this has to be +6, so x has to be what? 3. 2 times 3 is 6, -6 is 0. Okay, so we write that out. We have iron 3, oxide. Okay. For B, we have 1 tin atom, 2 chlorines that have a -1. So x has to be 2. Sn is 10, so if you didn't know that, you could look at your periodic table. Okay, so naming classification 3 is the only time that you have to do that first step where you have to find the oxidation state. Okay. When you write the formula for these, you can do the exact same thing. You can take the name, write out the oxidation state, and then swap, just like we did in classification 2. Okay? Think about it. If you look over here and you're given the name 10,2-bromide, what does that 2 stand for? The charge. Okay? So you're given that in the name. Okay? So you would write out 10,2. Bromide is -1 because it's in the it's a halogen, okay? And then you would just swap your numbers. So 2 goes there and 1 goes there. Okay, so writing the formula, you're given the oxidation state in the name. So all you have to do is, I always start when I write a formula is just go ahead and write both of my charges there and then just swap the numbers. Okay, and so this is less complicated because of that reason. You're given the oxidation state in the name. Okay, so let's write the formula. We'll start over here. So we have copper. So you would go, if you didn't know, it's Cu. We're given the oxidation state of copper. It's 2. And then we have iodine, or iodide, when it's got an anion here. And it's also in group 7. So we do like this. -1. Okay, so if we swap our numbers here, we get this. Zinc 2+, oxygen 2-. Okay, so what do we do here if we have a 2+ and a 2-, already equals 0? Yep, they just cancel. They already equal 0, so we get that. Okay, so writing formulas, very similar to the classification 2. Okay, this one right here is the hardest one of all because we have to find the oxidation state. Okay. So to do that, we have 1 nickel. So we don't know its oxidation state. We have 3 bromine. Has a -1 oxidation state. So X must equal 3. Y'all stop me if I'm going too fast. Everybody with me on that? Yeah. Not always. That's a very good observation. It does, but actually this will answer your question here. Okay. For this next one, you're going to see where it doesn't. It doesn't always work. Yeah, and you'll see why in just a second. Okay, so we go nickel 3. So that number we just found goes here. Bromide. Okay. Her question was, can't you just always pull this number that's over here? It seems to always happen where that number that's next to the metal, that subscript there, becomes the oxidation state. So that's a 3, and then we found 3. Okay, and that's been kind of a common trend. Some of you may have noticed it, some not. That your nonmetal's subscript seems to match up with the oxidation state. It does sometimes, but it doesn't always. Okay, and so this next example is an example where it doesn't work. Okay, so you would probably get this wrong. Okay, so Elizabeth, what you're seeing, you would think this would be 10-1, right? If you're looking at this one. Okay, but in fact, so let's do this. We have 1 times X plus 1 times -2. Okay, and so X equals what? 2. Y'all have questions? A lot of people. Anybody have questions? All right. Okay, so X equals 2 here. So Elizabeth, what she was thinking, you would have put a 1, wouldn't you? Yeah, and X is equal to 2. So you get 10, 2, the reason it doesn't work is because 10 here has a +2 and the oxide has a 2, and they cancel each other. Okay, so you end up with that 0. Okay, so that's why it doesn't work. Okay, pass these around. I meant to do this earlier. Okay. What's going around here, it's got the ionic charges of the atoms you already know at the top there. But at the bottom, there's what's called a polyatomic ion list. So the first thing we're going to do is look at what's a polyatomic ion. And then we're going to throw those into naming. Okay, so now you have all your classifications. And now we're going to throw in polyatomic ions. Okay, it's still the same idea, the same trend. Pick your classification. It's just a slight difference when you're using the polyatomic ions. Okay, so we're going to do quite a bit of practice with that if we have time, or we'll have a little bit of time here. Okay, a polyatomic ion, the list is at the bottom of the sheet. Okay, this is a group of atoms that bears a charge, an overall charge. So it's not just a single atom like we've been looking at. You know, fluorine has a -1. Okay, these are groups of atoms that have charge. Most all of them have a negative charge except for ammonium. Okay, it's the first one on there. It's got a +1. They're usually nonmetals, so they usually fit in for where you have your anion. Okay, so they're negative, so they're going to be like nonmetals. Okay, so they're going to come at the second part of the name, and where we've been using IDE is going to be a little bit different for our polyatomic ions. They usually have a 1, 2, or 3 negative charge. Okay, so here's another list. This is very similar to yours. But we have names for the group. So PO4, 3-. So 1 phosphorus, 4 oxygens. that whole group has a 3 negative charge. Okay, and so it's called phosphate. Okay, and so there's all these names here. Okay, and I'm going to give you this list. Okay, so you're not going to have to memorize the polyatomic ions, okay, because they can be very tricky. So look, you've got phosphate, and then on that group you have phosphite. Okay, so very similar. Sulfate, sulfite. So some of them can be very tricky to learn. Okay, but because I'm giving you the list doesn't mean that you don't need to look at it and practice using them and get familiar with them, because that's a kind of a common thing to try to, oh, well, she's giving me that, I'm not going to, use it or worry about it. But you really do need to be familiar with these and look. Okay, so on this list, what am I giving you on this list? I'm giving you the name, the formula, and the charge. So the oxidation state of all of these. Okay? So whenever you recognize a polyatomic ion, you go to your chart and you may need the name, or you have to find the charge. Okay? The charge is very important, okay, in naming. Just some little common things about polyatomic ions. The most common ones usually end in ATE, so sulfate, phosphate, nitrate. Okay, and then when you look at, so there's sulfite looks just like sulfate except for it has one less oxygen. So usually when you have one less oxygen, so there's PO3 and O2 versus 3, then it becomes ITE. So that's just kind of a little trick to kind of look at those. Okay. When you have these in names, or when we're trying to write formulas or name, it's the same thing. Okay? You just don't necessarily, your anion, your nonmetal, is a polyatomic ion. Okay? So what you do to get the charge is you go look at your chart. Okay? Whereas fluorine, we know it's -1, right? We know that. We don't have to look at anything. Okay? But a polyatomic ion, if you don't have these memorized, then you go to the chart, you recognize it's polyatomic, and then you go to the chart. Okay? And you get the charge there. Okay, so if we wrote the formula, we could do a calculation, which we're not going to do unless you really want to. I'm just showing it there. But for writing a formula, we can swap the states. Okay, and so what we do is we have magnesium. So the first thing we want to think about is, what classification is this? So which one was this from today? 1, 2, or 3? And we have magnesium and an anion. Classification 2, right? Because magnesium is in which group? It's in group 2, right? It's not a transition metal, so we know its oxidation state is always 2. Okay, so we write that 2 plus there. Okay, and then what we have to recognize is this ATE. Okay, we've just been seeing IDE, right? Okay, so that's if we had just a nitrogen. But nitrate is a polyatomic ion. Okay, so if you look at your chart there, it has a -1 charge. Does everybody see that? Okay. So we swap the states. The only thing here is if you bring that 2 over here and you put it next to that 3, what's that going to look like? It's going to look like 32, isn't it? Okay. So when you bring over a number greater than 1 here, you have to put that polyatomic ion in parentheses. Okay? Because if you don't, it's going to look like you have 32 oxygens. But really, you have 2 nitrate molecules. Okay? Okay, so we have some choices here. We're going to go through and see what we come up with. All right, so we're writing the formula. We know for any of the writing the formulas, all we have to do is swap states. Okay, we don't have to come up and solve for anything. Okay, if we use the shortcut. Okay, so if we have aluminum, okay, it's in group what on our periodic table? Group 3. So we're going to use our classification 2, right? Okay, so it's in group 3. Okay, and when we find nitrate, I believe that's the one we just had, it was NO3 -1. Everybody agree with that? If you find nitrate on your sheet? Okay. Okay, so when we swap, we bring a 1 here and a 3 here. Okay. But when we do that, we know we have to put parenthesis, then the 3. Okay, so that matches up here. Okay. See how you can mess that up? See here we're missing the 3 that we originally had there. Okay. B, C, and D all have Roman numerals next to them, so we know they fall under which classification? 3, because they're transition. Okay, so we would do the same. We have copper tooth, because we're given that, and then we have nitrate. So if we bring a 2 over here and a 1 over here, everybody agree with that? Matches up there. Okay, see what you get for C and D. So see if you get 1, 2, or 3 for each of these. Okay, so you got to find hydroxide. It's typically one that's easy to remember. Okay, so if I bring a 3 over here and a 1 over here, I'm going to get this. And I'm going to bring a 4 here and a 1 there. So I'm going to get that. Okay, so the key here is nothing really changed besides the fact that you had a polyatomic ion. So you just had to go look up what the charge is on the chart, and you still do the same thing. You just swap the states. So anytime we write formulas with metals, we have metals, we just swap the states. Write out your oxidation states and then swap them. Okay. When you name ionic compounds using polyatomic ions, this is where it becomes important that you recognize classification 2 or 3. Okay, if it's just a group 1, 2, or 3 metal, you just name the metal and name the polyatomic ion. It's as simple as that. Okay, the difference here is that when we're naming a polyatomic ion, you're going to name it exactly like it is on your sheet. Okay, you don't drop anything and add IDE. Okay, so think about it. If you had, you know, let's see, you have phosphate. Okay, if I drop the ATE and I say phosphide, now I'm talking about just a phosphorus atom. Okay, so you don't add IDE because then you go back to it not being a polyatomic ion. So you have to name it exactly like it is on the sheet there. Okay, if you need a Roman numeral, if it's a group 3, if it's a transition metal, then you have to put that in the name. Okay, and we know to do that we have to go through and we have to find our oxidation state. Okay, then you end with ite or ate because that's what polyatomic ions end with. Okay, or it could be, you know, if it's hydroxide, then it could end in IDE, okay, just because that's the name. But whatever the name is on that sheet, that's what you put. Okay, and then you just put it all together there. Okay, so if you look at these, we have calcium and nitrate. Okay. Kind of looks maybe a little more complicated just because you have a 2 out here, meaning you have 2 nitrate atoms. That was the formula that was derived there. Okay, but if it's in classification 2 because it's calcium and we name it, how are we going to name it? It's already up here. You're just going to simply state calcium nitrate. That's it, right? Because classification 2, we saw earlier with group 1, 2, and 3 metals, you write the name and then you write the non-metal name. So you write the name of the metal and the non-metal. Only difference here is our non-metal is a polyatomic ion. So we just write it in there exactly like it is on the list. Okay. B is our classification 3 because it is a transition metal. Okay. So we would have to find the oxidation state of our iron there. Okay, so that should actually be a plus. Never seen that before. Okay, and so it would be iron 3 phosphate because PO4 3 minus is phosphate. So let's work this one just to be sure we see it. Okay, so we know we are classification 3 here because we have a transition metal and then a polyatomic ion, which is our anion. So we have 1 iron atom, and we want to know what its oxidation state is. Okay. Okay, how many phosphate atoms do I have? 1. Okay, this is a very common mistake for students to put 4 or put whatever this is right here. Okay. But if it has no parenthesis, so if it had a 2 there, then you'd have 2. Okay? But it has 1. It's talking about the whole group. Okay? So that's a very common mistake. Okay, so we have 1 phosphate. Okay, so if you look at your polyatomic ion sheet, what's the charge on phosphate? I know it's already up here, but I just want you to see it. It's -3. Okay? So X is equal to 3. So we get iron 3 phosphate. And there's our final answer there. Only difference is we left this phosphate. We didn't change it to IDE. Okay, we just leave it like it is. Okay. If we look at A, B, and C, what classification are these? 1, 2, or 3? Exactly. They're in 3. So if they're in classification 3, here we have the ions written out, but we don't have to do anything, do we? We can write them out. That's great. We know them. But all we have to do is name magnesium sulfite. So you have to recognize that SO3 is sulfite. You would get that off your list. Magnesium SO4 is sulfate. So it's magnesium sulfate. Here's a calcium. We know it's in group 2, so it's classification 2. Calcium chlorate. That's ClO3. That's where you have to recognize it's a polyatomic ion. It's on your sheet, and so you name it like it is there. All right, now here's a mixture. So the last thing we're going to do here is I want you to name these 3. Okay, so you're going to have some classification 3s and some 2s. So if it's classification 3, you have to solve for X first and then name. Okay. I did B first because it's class 2. I know I simply state the name of the metal and the name of the anion, which here it's a polyatomic. So PO3, if you find it on your sheet there, it's phosphite. So that one's the easiest one. Everybody get that one? Remember to do that? Okay. So A and C, these are class 3. So I have to find X. I have to find the charge. Okay. So if I do that here, whoops, I have 2 iron atoms. And then I have 3 sulfate atoms. So X has got to be 3. So it would be iron 3. SO4 is the sulfate. Okay. Remember, if you need to, put a bracket around this. That CO3 is carbonate. You just have one of those. Okay. You don't have 3. You have 3 oxygens, but not 3 molecules. You have 1. Okay, so if we did what is your charge for, or what is CO3? It's carbonate, and it has a charge of, very good. So X must equal what? 2. So we're going to have lead 2 carbonate. So what we just did, here's some more explanations. So there's our answers there. So you can just break them down and look at them this way. So that should be. This takes practice. It's a lot for one day, but it's best to just get all our scenarios out of the way and then practice. If you run into problems, then please let me know, and I can try to help you with these. I have a few exams for people that weren't here. Stratton, Will, Jonathan, Tanisha, Blake, Christopher. So y'all need to come get your exam. And I will see you all in a few minutes in lab. I'll see you at 11. Please be on time. I will count off points off your lab today if you're late. So please be there at 11. Oh, there you go. All right, is Will here? Jonathan? Tanisha? Woo. Jonathan? Chris. There you go. Okay. There you go. And no Will still? Okay. Good deal. See y'all in a few minutes. Okay. For some of it, yes, but we'll try to print you some. You just have to remind us in lab. So Janice can print it off. Yeah. Mm-hmm. Yes. Okay. No, I have not. I have been out of town, so I will probably get it. Usually, if it's makeup, it may take me till Friday because I just got about 60 exams to grade today. But I will try to get it done before then. But any makeup work, I usually try to do on Fridays is my makeup day. But I'll try to get it done before that. But thank you. Let me know.